All right, guys, here's a review from previous sections in chapter 3. So I'm going to pause this and I want you to go through and do these. So you want to write all the pairs of each of these. Now remember, each of these are in pairs. And then I want you to write their relationship. So what I mean by their relationship is, are the angles congruent? Are they complementary? Are they supplementary? Is there no relationship? So go through and do all these, and then you can check your answers against mine. All right, guys, this is what you should have gotten. Please check your answers against mine and make any corrections, and then make sure to ask if you have any questions. All right, so let's go to example 1 now. The distance from a point to the line. Now, this can be a little confusing. You'd think it'd be pretty obvious, but if we have a point and we have this line down here, okay, if I asked you, find the distance from this point to this line, well, you know, maybe you can find this distance, which would be a different distance than this distance, which would also be different than this distance, which would be different than this one, which would be different than this one, and so on and so forth, right? Or like if you extend this line out, maybe it's way over here. All these lines are different lengths. So when we're talking about finding the distance from a point to a line, we always want the shortest point, or the shortest distance, I'm sorry. So guys, that shortest distance is always the length from the perpendicular segment from the point to the line. So in other words, the distance that I want would be the distance from this point that is perpendicular to this line. This is the distance here. And the reason this is the distance is because this is the shortest distance. Okay. Now, a perpendicular bisector is just a line segment array that is perpendicular. I'm just going to use the symbol to a segment, but it also bisects it, so it intersects at the midpoint. All right, if I look here at example 1, I want to find the distance from this point to this line here, okay? Now notice there's 1, 2, 3 points on this line, but there's really several more than 3 points, just 3 labeled points. So from this definition right here, I want to find the distance from this point to this line, but the shortest distance would be right here. This here would be the shortest distance. Okay, so just a reminder, the distance formula is x2 minus x1 squared plus y2 minus y1 squared. Okay, and I want to find the distance between point A, which is -3, 3, and point C, which is at 1, -1, and that's because C is the point on the line where it's perpendicular to it. Okay, so I could say this is the x coordinate of point 1, y coordinate of point 1, x coordinate of point 2, y coordinate of point 2. So I could say the distance is, well, x2 minus x1, guys, that's 1 minus a -3, which would be a 1 plus 3 squared, plus y2 minus y1, so -1 minus 3 squared. So this is just 4 squared plus -4 squared. Now 4 squared, guys, is 16. And -4 squared is also 16, which is the square root of 32. And you can leave it just like this, that's fine. All right, guys, there's 3 more theorems here. These are pretty straightforward. So the linear pair perpendicular theorem tells us if 2 lines intersect to form a linear pair of congruent angles, so it's both a linear pair and they're congruent, then the lines are perpendicular. You guys should know that because if they're a linear pair, they equal 180. If they're congruent, that means they're the same, so each of them would have to be 90. Well, definition of perpendiculars, they cross at a 90-degree angle. All right, so the second one is the perpendicular transversal theorem. So it says in a plane, if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other line. So in other words, Because H and K are parallel, then that means if it's perpendicular here, it also has to be perpendicular here. And if you look, that should make sense because this angle and this angle are corresponding angles. Okay, lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, so in this one, we know that we have two perpendicular lines here, then that means that M and N have to be parallel to each other. That once again should make sense as well because these are corresponding angles. All right, guys, let's look at example number 2. So I'm going to write a proof here. It says use a diagram to prove the perpendicular transversal theorem. So in a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. That's what the theorem tells us. So our given here, guys, is that line H and line K are parallel, so H is parallel to K. And I'm also given that angle 2 is 90 degrees, okay? Now I want to prove that angle J is perpendicular to angle K. I want to prove that it's perpendicular to the other line. All right, so let's go ahead and start. So H is parallel to K, and angle 2 equals 90. These are both given. Well, guys, if I look up here, what do I know about angle 2 and angle 6? I know that angle 2 is congruent to angle 6 by the corresponding angles theorem. Okay, and if they're congruent, then they have to be equal by the definition of congruence. Okay, well, guys, if I know angle 2 equals 90 degrees, couldn't I substitute 90 degrees in for angle 2? So I could say that 90 degrees equals angle 6. So I know this is a 90-degree angle. And if this is a 90-degree angle, guys, sorry, that would be substitution. So if this is a 90-degree angle, doesn't that mean that J has to be perpendicular to K just by the definition of perpendicular? So that's what perpendicular means. They cross at a 90-degree angle. All right, let's look at one more example, then we'll be done with this section. So it says the photo shows the layout of a neighborhood. Determine which lines, if any, must be parallel in the diagram. Okay, now I know it's kind of hard to see in black and white, but there is a right angle here. There is a right angle here. And there's a right angle here. All right, guys, I know it's hard to see too, but this is street S. This is street T. This is street U, street P, and street Q. All right, so given that this angle and this angle are both 90-degree angles, I can say that this line and this line are parallel. So I can say S is parallel to T, and that is by the lines perpendicular to a transversal theorem. Okay, so if two lines are perpendicular to the same transversal, then those two lines have to be parallel. Okay, well also, if I look at this right angle here and this right angle here, I can say that this street and this street, so P is also parallel to Q by that same theorem as well. I can conclude nothing more about this diagram. It looks all day like all of these are perpendicular, but nothing tells me that for sure. And so remember, we can't assume something.